The last lesson in chapter 2 is something called related rates. So a rate just means you're comparing two things, but they have different units. Like if I'm comparing the height of two people in our class, we're probably measuring their heights in the same units, be it metric or US standard units. That's not a rate. But a rate could be something like a speed in miles per hour. It could be something like profits for a company in dollars or thousands of dollars per month. Or it could be the rate at which your business is expanding. And a lot of these rates are all measured by the amount of time that takes place. So we're going to take a look at these, but first we're going to need to use a skill that we just handled in the last lesson, implicit differentiation. So in all of these situations, we're going to be needing to derive normal equations we might see somewhere else, equations you've learned about in maybe geometry or algebra or some other previous class, maybe even a science class, and then derive those with respect to time. Derive each of these with respect to time. So it's the exact same thing you've been doing when you've been taking derivatives all chapter long. We're just using a different letter. So that should have little to no effect on what happens, except when the letters don't match up, like this. Here's the derivatives for each of these. And notice that whenever the variables don't match up, which is just about every time, remember to put in dA over dt, dB over dt, and dC over dt. You'll notice that a lot of these are recognizable equations. We have the Pythagorean theorem, the area of a circle, the volume of a sphere, basically sine opposite over hypotenuse, but the hypotenuse was a given number. And the only one I haven't derived yet is this one, because if I was to derive it, I would need to use the quotient rule here, and I just want to give you this little tip right now. You can make this problem slightly easier by rewriting it this way before deriving. If you can do that one little step, there's no quotient rule to deal with. You don't even have a product rule here because tangent of 20 degrees is actually a constant. It's just a number. Remember, you only have to use the product rule if you have two variables or two functions. So that's the first step. Can you use implicit differentiation with t instead of x? And the answer is yes. I believe that you can. You're going to be okay. So here's the next part. So here's a quick definition for related rates. Okay, it's not a definition, but it's a definition of calculus in a way. And so related rates are really just comparing two different rates or more than two rates. And so there's a really simple set of instructions, but since these are all word problems, I would not classify this lesson as anything in terms of simple. The steps are pretty easy, but the hardest part is going to be coming up with the correct equation to match the situation. And everything else, plugging in numbers, taking the derivative implicitly, and actually plugging in your data at the end, that's pretty easy to do. It's all about reading the situation. This example up here isn't so much about one of these related rate problems. It is about understanding how the variables work into this. Each of these three parts might be something you'd see in a related rates problem, and they represent something of an equation or a variable. But when you look at them, whenever you see a rate, inches per year, cents per day, feet per hour, you're talking about a derivative. The easy part is to say, hey, I'm growing at 3 inches, or I'm losing 4 cents, or the radius is increasing. So the plus or the minus represents the change. But the important part is to be able to figure out what kind of derivative do you have. Since all of these are going to be rates of change, they're all going to be related to time, whether it's years, days, or hours. But the other thing is, what's growing? Well, I think it's John's height. What's changing? Well, that's the amount of money. Whether you do it in cents, dollars, or money, you could even do profits if you like. It depends on the actual question. And then finally, for the last one, while the feet are growing, the feet are changing, it really is a radius that is changing. So we're going to put dr dt